in problem number 1, what is the y-intercept, and also where do I look to find it?
You could either look at the graph or look at the equation.
Good. Okay, so where on the graph, where do you look?
You look at the y-axis, and you see where x equals 0.
Good. So if I look on the graph, I notice that right over here where I put my blue dot, my graph is passing through the y-axis, and it's passing there at 0, 5. So that is my y-intercept. It's 0, 5. But where else can I look? You said the equation, right? Okay, so don't forget, and I'll write this down, don't forget that standard form is f of x equals a times b to the power of x. And so whatever number a is, whatever that is your y-intercept as well. So on our graph, or on our equation, you can see that it's also right here. That's the y-intercept. It's 5. So you can also write a equals 5. All right, if that's the y-intercept, then what's the growth rate? And problem number 1, what is the growth rate? So for the growth rate, we can also look right at the equation. A is the y-intercept, B is the growth rate.
2.
So on problem number 1, the growth rate is 2. So we can write B equals 2. Because again, you just look right into the equation. You don't have to do anything else. Pretty easy. Okay, cool. Now, is my graph increasing or decreasing?
Increasing.
Good, it's increasing. And remember, when we try to figure out if something's increasing versus decreasing, you always look from left to right. So you want to think, does the graph look like a mountain that you're about to climb, or does it look like a slide that you're going down? Okay. So in this case, from left to right, you're going up, it's increasing. And then finally, let's take a look at end behavior, because that's always the trickiest thing for a lot of people. So the most important thing to just remember is that these statements that I'm circling, boxing right here, those are always the same. And those are just telling you where to look. So when I say, let's look at the one on the top. When I say, as x approaches infinity, positive infinity, which side of the graph is that telling me to look at? The right or the left?
Right.
So this is just telling me to look on the right side. And the other one is telling me to look on the left side. So on the right side of my graph, what is happening to f of x? Where is it going?
Up.
It's going up. So what do we write?
Infinite.
Infinity, yeah. F of x is approaching positive infinity because it's going up, 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 up towards infinity. Now on the other side, on the left side of the graph, where is f of x going?
To 0.
Good, to 0. Remember that end behavior is always, there's only 3 options. It's either going up to positive infinity, down to negative infinity, or if it looks like it's gonna like land on the ground, it looks like it's kind of getting close to the x-axis, it's never gonna get there. So we say that f of x is approaching 0. It's trying to get to 0. Okay, so at this point, do I have any questions on figuring out the y-intercept, figuring out the growth rate, figuring out if it's increasing or decreasing, or figuring out the end behavior?
Miss Lopez?
Mm-hmm.
On the test, will it be the same as this, or we're going to have to calculate everything?
On a test, it'll be like a multiple choice question. Okay, so actually today, in a little bit, I think we'll see a couple of examples of what it would look like more on a test. Oh, here's a good question. How can you tell the growth rate just from looking at the graph? So let's say you don't have this equation in front of you. Let's say you get a graph, no equation, so you got to figure out the growth rate. Very, very good question. So what you can do in that case is take a look at all of the perfect points that you can find. So actually, let me make a little bit of space here. Matter of fact, let me just add, hold on. Let me add a little sticky note. Okay. All right. So let's say, okay, I need to figure out the growth rate. I need to figure out, but I don't have an equation. So I need to somehow find another way. Well, what you can do is make a table. But the most important thing when you make a table is to just make sure that the X values are going in order, like 1, 2, 3, and 4, and so on. So you just want to make sure you're not skipping any numbers on the X values. And then let's just quickly fill in. We have those numbers here, so let's fill them in. Actually, I'll put 0 as well. So we have 0, 5, 1, 10, and 2, 20, right? And obviously, if you have more numbers, the better, but this is all we've got. And then remember yesterday's class, whenever you have a table, how do you figure out the growth rate? Who can remind me? Alyssa, you got it. Can you put it on public? You got it. Think about, we got to work our way backwards to figure out the growth rate. Good, Alyssa. We're going to divide because exponential functions grow by multiplying. They grow by multiplication. So to figure out the growth rate, you got to go backwards and use division. So all you have to do is you just go backwards. You take this number, divide, divide, divide. 20 divided by 10, 20 divided by 10 is 2. So that's your growth rate. So anytime you have a table, and we'll do this a little bit later, probably if we don't get to it today, we'll definitely do it tomorrow to just review it. But anytime you have a table, you can find out the growth rate just by working your way backwards and divide, 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 divide. So if you have a graph like this one, and you don't have an equation on it, all you have to do is make a little table and then go from the bottom and divide to figure out what the growth rate is. So good question. Any other questions about this problem? Okay, one more question is to explain the fill in the blanks one more time. Yes, I will explain it one more time. The most important thing is to remember when I write these two statements down, we know that with algebra, a lot of times with algebra, we write things in algebraic form instead of writing things as words, okay? So this is just kind of like a shortcut way of saying the following. So this one is saying on the right side of the graph, and the other one is saying on the left side of the graph, right? Because as x approaches positive infinity, where is x approaching positive infinity? All the way to the right. So in this direction, x is going towards positive infinity. On the other side, x is going towards negative infinity. So when you see, okay, x approaching positive infinity, that's just telling you, okay, look on the right side of the graph. And then when you see x approaching negative infinity, it's just saying, oh, look on the left side of the graph. And all you're going to do is look on the right side and then determine if your function is going up, down, or to 0. That's all you have to figure out. So a matter of fact, let's go ahead and take a look at the second example so that you can kind of like practice that one more time if you're still having a little trouble with it. So on the second example, let's just go, I think the first 3 questions, most people are not going to have any issues with. So let's go through them. So what is the y-intercept on example 2?
-6.
-6, good. So A is -6, or 0, -6. What is my growth rate?
0.7.
Good. Is the graph increasing or decreasing?
Decreasing.
Oh, careful. This one's trickier. Remember to look from left to right. Start on the left side. If you walk towards the right side, would you be going up or down?
Oh, up.
Up. So we've got, again, increasing. And now let's practice filling in these blanks. So as x approaches positive infinity, where am I looking here?
To the right.
To the right. So I'm going to circle this right here. On the right side of the graph, where is the function going? Up, down, or to 0?
To 0 because it's trying to get closer to the line.
Good. It's getting closer and closer to the x-axis, but it's never going to touch it. It's getting closer and closer, but it's never going to touch it. So f of x is approaching 0. As x approaches negative infinity, where am I looking here?
To the left.
Now I'm looking on the left side. So I'm looking over here. Where is my function going? Up, down, or to 0?
Down.
Down. So when it goes down, what do I write in my fill in the blank? What was that?
Negative infinity.
Negative infinity. Okay, so it's just a new way to write things down, but make sure you don't overthink it, okay? Because really all you're trying to say is just you're trying to tell me if the graph is going up to infinity, down to negative infinity, or towards 0. On the right side of the graph, what's going on? On the left side of the graph, what's going on? How do we feel now? Any questions? Any remaining questions on this topic right here? Why is the first one 0? Okay, so the green, where I circled it in green, as x approaches positive infinity, can anybody explain why? Why does it say f of x is approaching 0?
It's trying to get close to the line, but it never can.
It's trying to get close to which line?
X-axis.
The x-axis. And think about the x-axis like the floor. Okay, it's like if you have a plane that's landing, it's landing on the ground. So that's the x-axis is 0. But you can have it 2 different ways. You can have a plane landing towards the ground. So f of x is approaching 0 from the top, but it could also be approaching 0 from the bottom. So in this case, the graph, like we said, it's increasing. You're walking up that hill, but that hill is trying to touch the x-axis. It's trying really hard. It's going to try its hardest to get there, but it never will. So it's approaching 0, but it's not going to touch 0. And so that can happen from the top and that can happen from the bottom. Any other questions? Anything else? All right, cool. So we're gonna spend a little bit more time graphing today, and then maybe we'll get to some real world problems at the end. If we don't get to those today, then we'll just do them tomorrow. That's totally fine. But let's just see how far we can get with graphing. I just wanted to review this one more time. The parent function is f of x equals 2 to the power of x. Can somebody explain like, what exactly is the parent function? Who remembers from yesterday's class? Why do we have one?
The most simplest.
Mm-hmm. Yeah. Yeah, you've got it. It's the most simple type of exponential function. In fact, I wrote it down over here. The parent function is the most basic, the most simple. All of the numbers are whole numbers. It's positive. It's it's what we like to compare everything to. So throughout today's class, I'm always going to be asking you, how does this compare to the parent function? Because we always want to kind of think about the parent function as like the OG. It's the original, okay? And everything else, every other graph, every other exponential graph is just adding to the parent function, multiplying the parent function, making the parent function negative. It's just changing the parent function in some way. So when we're graphing these functions today, I always want you to think, okay, how does this compare to the parent function? What's different? Does it go up? Does it go down? Does it get longer? Does it get shorter, wider? What's happening? Okay, so I just want us to just remind what is the parent function, and then as we go through today's class, we'll start comparing things to the parent function. So real quick, let's just remind ourselves, what is the y-intercept of the parent function?
1.
Good. A equals 1. Because remember, f of x equals a times b to the x, to the power of x. And in this case, the parent function is just 2 to the power of x. So it looks like there's no a, but really what's invisible in front of the 2?
Invisible 1.
An invisible 1. So I have 1 times 2 to the power of x. So my y-intercept is 1, and I didn't write this down, but let's just make sure that the growth rate equals 2. Okay, does the parent function grow or decay? Is it increasing or decreasing?
Increasing.
Increasing, so it's growing. And let's do the end behavior. So here's one more chance to practice the end behavior. I'm going to write the beginning of it, and I want you guys to think about what's going to go in the blanks. Okay. So as x approaches positive infinity, where is f of x going?
Infinity.
Good. You got it, guys. Good job. So again, this is the right side of the graph. So over here. So f of x is going up to infinity. And as x approaches negative infinity, where is f of x going?
0.
To 0. Good. It kind of looks like it's touching the x-axis, but remember in yesterday's class, I showed you when you zoom in really, really far, even if it looks like it's touching, it's not. So 0. All right. So that's my parent function. Now let's start doing some stuff to the parent function, and let's just see what happens. So what we're going to do is we're going to graph two functions on the same coordinate plane. So I have f of x equals 2 to the power of x. That's the parent function. And then I have g of x. And remember, g of x is just all of those g of x, f of x, h of x, whatever letters you see there, that's just the name of the function. That's just what, like, my name is Miss Lopez, you have a different name. So it's a way to distinguish between the two different functions. We give them different names. So we have the parent function, and then we have this new function, g of x. Now, just with the equation, without any graphing, we're not going to do anything yet. Just by looking at the equation, what's different?
There's a g of x.
There's a g of x, so it has a different name, but the equation itself, what's different in there?
Oh, the b is in the front now.
Okay, so be careful because that's not the b anymore. We're going to call that something else. But what operation are we using in that function?
Slope intercept.
It's not slope. It looks like it, doesn't it, though? It looks like y equals mx plus b. But where's the x?
As an exponent.
As an exponent. So it's not slope, even though it looks like it, it's not slope intercept form. It's still exponential function because we still have an exponent. It's just that we're adding something to it to the end of it, okay?
A 1.
In this case, a 2. We're adding that 2 right there, we're adding it to the end of the function. What do you guys think is going to happen when we add a number to the end of the function? Let's just throw out some possibilities.
Oh, wait, is it going to be doubling? Wait, no, it's a linear function.
But remember, it's not. I know it looks like one, but we still have an exponent, don't we? We still have an exponent. So we know that the shape will still probably look the same as our original. But when you add a number to the end of it, how do you think it might transform the function? Any guesses before we graph it?
It will have an ending point. I don't know.
Maybe. That's okay. No, that's a good guess. Maybe it'll actually end somewhere. Any other guesses? Because remember, like a lot of different things can happen. It could shrink, it can expand, it could flip over to the other side. Maybe it'll go up, maybe it'll go down, maybe it'll go to the left, to the right. There's a lot of different ways that this function could be transformed. So I'm going to give you guys one more opportunity to make some guesses, and you can do it in the chat as well.
Oh, it will go to 0.
Maybe it'll go to 0. Mm-hmm. Anything else? Okay, so let's actually graph it and let's see what happens. Well, in order to graph, I'm going to fill in my table. And once I've filled in my table, I can put the dots on the graph. So let's start by filling in the table. I got to plug in all of these values, right? Now, which one should I start with? What number should I plug in first?
0.
Sure, yeah, let's plug in 0 because that one's kind of easy, right? What is 2 to the power of 0?
0.
Not 0.
No, it's 1.
It's 1. Good. There you go. Anything to the power of 0 is 1. So 0, comma 1. Okay, then I'm going to go from there. F of 1. What's 2 to the power of 1?
2.
2. Nothing changes. And then f of 2. 2 to the power of 2.
4.
4.
Good. Okay, now let's work backwards. Let's do the negatives. 2 to the power of negative 1.
1.5.
0.5.
0.5 or 1/2. Remember what happens with a negative exponent, it becomes a fraction. What about f to the power of negative, or 2 to the power of negative 2?
1/4.
Good, good, good. Remember, because what happens is this is now 1 over 2 squared, and 2 squared is 4. So 1/4. What's 1/4 as a decimal, by the way?
0.25.
0.25. Good. All right. So we've got our values. We're all good on f of x. So now we got to fill in g of x. Well, g of x is just the same thing as f of x, but then what do I do to the f of x? Mathematically, what is it? Yeah, it's just telling me to add 2 to whatever I got with f of x. So if you don't believe me, let me show you real quick. Let me plug in 0 this time. So g of 0 is 2 to the power of 0 plus 2. Well, we already got 2 to the power of 0. We know that 2 to the power of 0 is 1. So this is 1 plus 2. So I get 3. So basically what it's telling me to do mathematically is to take whatever I have in the red column, add 2 to that number to get what I have in the blue column. So I can basically go down the line and just add 2. So 2 plus 2 is 4, 4 plus 2 is 6, 0.5 plus 2, well that's going to be 2.5, and 0.25 plus 2, that's just going to be 2.25. So we actually got all the hard work done before that, and at this point, all I needed to do was just add 2. Any questions up to this point about how I got those numbers?
Mm, 4, 5, 6. Okay.
Yeah?
I'm gonna take a quick picture.
Okay, take a quick picture. Now, I do want you guys to graph this, so please make sure that you sketch your graph, just like we did yesterday. The y-axis goes up to 8, and the x-axis goes up to 5. So do a quick x and y-axis, and then you'll be ready to graph these numbers. So I'm going to start with the red graph, and I'm going to put them both on. So if you happen to have any colored pens or different colored pencils or anything like that, it's going to be helpful because then you can use 2 colors and it'll look a little bit nicer. So -2 comma 0.25, -1 comma 0.5, 0 comma 1, 1 comma 2, 2 comma 4. Here's f of x. So f of x, we already knew what that was going to look like because f of x is just the parent function. So it looks exactly like the one I had on this slide right here. It's my parent function. G of x was the parent function plus 2. So let's see what happens when you add 2. So now I've got -2 comma 2.25, -1 comma 2.5, 1 comma 3, or 0 comma, wait, 0 comma 3, 1 comma 4, and 2 comma 6.
Do they have the same endpoint?
Good question. What is their endpoint? Where are they both going towards?
Infinite.
Infinity. So in a sense, yes. But here's something, it kind of looks like they're going to intersect, doesn't it? Kind of looks like they are.
Yeah.
What's basically happening is they're getting closer and closer and closer and closer and closer and closer together, but they won't intersect. So it's the same idea, like as when it's going down towards 0, same thing happens. They get closer and closer and closer and closer and closer, but they're not actually going to intersect. So take a little moment to finish copying it down onto your notebook and doing your sketches. And then also think about on the graph itself, what's physically happening to go from f of x to g of x. All right. So hopefully you've got your nice sketches on your notebook, and let's talk about physically on the graph, what is happening to go from f of x to g of x? Remember, f of x is the red one, g of x is the blue one.
Go up to?
Yeah, it goes up 2 steps. So if you kind of look at the y-intercept of both of these functions, if you just look at the y-intercept, you can tell pretty easily that f of x, if you kind of just shift it up 2 units plus 2, you end up at g of x. So when you add a value to the end of the function, like we added 2 on the end of it, that actually transformed the function by bringing it upwards. It brought it up 2 steps. So now let's kind of look at let's compare a couple of things. I'm going to erase some of this math here. So for f of x, what is the growth rate?
Two.
Yeah.
Yeah, it's 2. So the growth rate, hold on, let me organize this. Okay, the growth rate is 2 for both of them. What is the y-intercept for f of x?
F of x 1.
It's 1. Mathematically, how do you get the y-intercept for g of x?
Add 2?
Add 2. So 1 plus 2 gives me 3. So anytime you have a transformed function, and you can always tell when you have a transformed function because it has a number at the end of it. It's either going to add a number or it's going to subtract a number. You can always figure out the y-intercept of that function by thinking, okay, what's the y-intercept of the parent function and what do I add to it to get my new function? So you can either do that, or what's another way to figure out the y-intercept always with any equation in the world? What number should I plug into it?
0.
Yeah. Anytime it asks you what is the y-intercept, just plug in 0 and see what you get. Because we know that the y-intercept is whenever x equals 0. So I could do this mathematically, algebraically as well. I plug in 0, I get 1. 1 plus 2 is 3. So a couple different ways to do that. But how do we feel? Do I have any questions on this function and its transformation? Okay. All right, let's take a look at another one. So now I've got these two functions, but do I have the parent function anymore?
No.
No, no parent function. I have something else. So before we begin, let's actually think about how is f of x different from the parent function? What was that? How is it different? What's different about it?
It is a decimal?
It has a decimal, exactly. So let's start with that. Okay, we know that the y-intercept, or not the y, yeah, actually. Let's talk about both things. Let's talk about the y-intercept and the growth rate. What is the y-intercept?
1.
Good. The y-intercept is 1. Remember that there's an invisible 1. So I could rewrite this as f of x equals 1 times 0.7 to the power of x. So there's like a little invisible 1 right there. So the y-intercept is 1, the growth rate is 0.7. And since the growth rate is a decimal rather than a whole number, what do you think? Give me some possibilities. What do you think is going to happen to that graph?
Is it going to be a negative infinity?
So maybe it'll point downwards rather than pointing upwards. That's one
Yeah.
possibility. That's a good guess. Anyone else have a different guess? So let's actually find out. The best way to figure it out is by actually graphing it, right? So let's actually graph it, see what happens, and then we can predict what'll happen to g of x. So again, we're going to plug in each number and see what we get. So starting with 0, because we know 0 is the y-intercept. We actually already know what the y-intercept is, but let's show it mathematically. Anything to the power of 0 is?
1.
1. Good. So the y-intercept is 1. 0.7 to the power of 1 would be what?
0.7.
0.7 doesn't change. F of 2. Now I've got 0.7 to the power of 2. Now you can use your calculator for this. You can also think about it like this. What is 7 to the power of 2?
14 and
49.
49, good. So 0.7 to the power of 2 is just going to be 0.49. It's like an easy way to do that in your head instead of having to use a calculator. So I have 0.49. Okay. Just from these numbers, what seems to be happening? What's the pattern?
It is increasing. No, we're going from up to top. I mean, from up to bottom and bottom to top.
Yeah, from top to bottom always.
Oh, it's decreasing.
It's decreasing. It's getting smaller and smaller and smaller, right? Now let's go backwards. Let's keep going. F of negative 1. 0.7 to the power of negative 1. What does that actually turn it into?
One over 0.7.
Yeah, 1 over 0.7. Well, in your calculator, you can just go ahead and do 1 divided by 0.7. What are you
Say
getting?
1.42857.
1.42857. That sounds about right. Let me double check. Yeah. So I'm going to simplify 1.43. And then finally, f of negative 2. That's 0.7 to the power of negative 2. How do I rewrite that?
One over 0.49.
1 over 0.49. Good. Same thing with your calculator. What is 1 divided by 0.49?
2.004.
2.04. Good. Okay, we got all our numbers. So again, from the beginning, we knew the growth rate is a decimal now rather than a whole number. What seems to happen when the growth rate is a decimal? Is it going to be increasing or decreasing?
Decreasing.
Decreasing, yeah. So let's go ahead and put these numbers. I'm going to graph f of x, and then later, afterwards, we'll graph g of x. So negative 2 comma 2.04. That's going to be real close to the 2. Negative 1 comma 1.43. That'll be somewhere around here. 1 or 0 comma 1. 1 comma 0.7. And 2 comma 0.49. So I'm just Just doing my best to get those numbers. Obviously, it's not going to be perfect. And there's my graph. So how did this compare to what we thought? Because we were saying, okay, maybe it's going to go down towards infinity, but it's not going down towards infinity. Where is it going down towards?
0.
Towards 0. Good. So it's similar. What happened is the parent function, which looks like this, the red one over here, is increasing because it's growth. It's exponential growth. It's growing. Here, I have decay because the growth rate is a decimal. So think about it. When you multiply something by a decimal, it gets smaller and smaller. So the function is a decay function. It's going down. It's decreasing. So there's my graph. Go ahead and take a moment to graph yours. Try to get it at least to get the same shape as mine. It doesn't have to be perfect, but the most important thing is to get the same shape. And start thinking about what is g of x going to look like in comparison. All right. So mathematically, what do I do to all the red numbers in that column?
Subtract 3.
3.
Good. I'm taking away 3. I'm subtracting 3. So mathematically, I'm subtracting 3. Physically, what's going to happen to the graph?
It will turn into a negative.
And what way? So be more specific. So what should I do to the red graph? If I were able to pick it up and then put it down, what am I going to do?
Flip.
Flip it?
Mhm.
Do we agree?
I
Yes.
think you should flip it because since it's a negative, it has to go to the left side. Wait, hold on. I'm getting a little.
What happened over here? Remind me. If I could pick up my red graph and put it back down, what did I do in this example?
Since it was increasing the red line, well, we duplicated the red line to make it go up.
It went up, right? So I could pick up my red graph and put it back down 2 steps above. So I picked it up, moved it up 2 steps, and put it back down. So in this case, if I could pick up my red graph, what am I going to do with it?
Put it down
Where?
to the negative side.
How many units?
3.
3 units down. So I already know, I haven't graphed it yet, but I know where is the y-intercept going to be?
-2.
-2. So be careful with your words because I am not flipping it. I'm not turning it or flipping it or moving it in this way. I'm literally, if this was my graph, if this pencil was my graph, I pick it up, move it down, and put it back. I'm not flipping it. I'm not turning it. I'm not twisting it. Just pick it up and put it down. So I know that this is going to be my new y-intercept, and let's just get all the values so I can be more accurate. So I'm subtracting 3. So 2.04 minus 3, what do I get?
Negative 0.96.
Negative 0.96.
Mhm.
2.04 minus 3. Yes, good. 1.43 minus 3.
Negative 1.57.
Good. 1 minus 3.
-2.
-2.
Negative 2. 0.7 minus 3.
-2.5. Wait, I think
Close.
-2.3.
Negative 2.3. And 0.49 minus 3.
Negative 2.51.
Good. All right, so there are my actual values. Let me go ahead and plot them and put my graph down. So negative 2 comma negative 0.96, that's going to be very close to negative 1. Negative 1 comma negative 1.57, that's about halfway between negative 1 and negative 2. I already put my y-intercept down. Then I have 1 comma negative 2.3. It's a little bit further down. And then 2 comma negative 2.51, a little bit further down. So there it is. Okay, so again, all I really am doing is I'm picking up the red graph and setting it back down 3 steps lower. I'm not turning it, I'm not flipping it, I'm not twisting it, I'm not rotating it, I'm not reflecting it, nothing like that. It's just moving. And whenever you have, if you look at a function equation and you see that it's adding a number to the end of it, we know that that's going to move it up. And then if it's subtracting a number from the end of it, we know that it's going to be bringing it down. And that's all that you have to remember, because that's going to help make life a lot easier. So take a few more moments to finish copying down, and take this opportunity. If you have any questions, go ahead and send them to me in the chat, out loud, whatever you need. Okay, how did I get the numbers for g of x? Can anybody explain one more time, how did I get those numbers?
Well, since it turned into, hold on, I have to find
That's
a way
okay.
We subtracted 3 from f of x.
Yeah, all we do is, because look at the equations. The equations are almost exactly the same. It's just that here we
instead
have,
from the other side, it has a -3 instead of a +3. So we have to subtract it.
so we're subtracting 3. So all I did was each of these numbers, 2.04 minus 3 gives me negative 0.96. That's all we're doing. So I'm just subtracting 3 from each one. That's all. Okay. All right. So now I think I have, yes. So now I have, because somebody was asking earlier, what does this look like more on a test? So I'm going to show you guys a couple more questions that are on the same topic, but more like what would look on a test. So here's one. So take a look at the functions f of x and g of x below. Describe using words how you can go from f of x to g of x on the coordinate plane. So using words, how do I go from f of x to g of x?
Adding 3.
Adding 3?
Well, we start from -2 because, oh wait, hold on, my bad, I'm sorry. I thought g of x was f of x.
There we go. So that's the first things first. Figure out which one's f of x, and then what?
We subtract 2. I'm sorry.
Good. Subtract 2?
3.
1, 2, 3. Oh.
3. You got it. So subtract 3. So you must subtract 3. So mathematically, I'm subtracting 3. Visually, physically, we're going to use these like transformation words. So we must shift the graph. Remember, because shift when you shift something, you're moving it up, down, left, or right. So we were shifting the graph 3 units down. So to go from f of x of g of x, you must shift the graph 3 units down. Now let's quickly review, because we know there's actually a mathematical algebraic way to say the same thing. So I'm going to quickly review. So algebraically, we would write it like this. We would say that g of x is f of x minus 3. F of x minus 3, because it's just telling me, okay, take f of x and shift it down 3 units. So g of x is f of x minus 3. And the reason I want to bring this up is because on a test, that's what it's going to look like. On a test, you're going to see it algebraically rather than using up all of those words. See what it does? It just algebraically, it's taking those same words that I wrote down and condensing it into a little equation. And that's what a lot of times is confusing. It looks confusing, but we just have to learn how to translate that statement into words. So any questions on how to write that down algebraically? Okay. Anybody still need a second to write this down? Take any notes? All right. So now I want you guys to do the same thing with this example. Write it down using words and then write it down using algebra. So do the same exact thing using words and then using algebra. Take about a minute and a half to do that. Okay, a couple of seconds remaining. All right, using words. Who can explain using words what is going on here?
To go down from f of x to g of x, you must shift the graph 3 units up.
Good. To go from f of x to g of x, you must shift the graph 3 units up. So this time we're going up. So algebraically, can I have a different volunteer give me the algebraic equation?
For g of x,
Yeah, because g of x is the ending point. So how do I get to g of x? Remember, go ahead.
we just subtract from f of x. So we put f of x equation, then we put minus 3.
Okay, so be careful though, because to get, we take f of x physically, I'm taking f of x and I'm bringing it where? Up or down?
Oh, up. So
right?
adding 3.
So we're adding 3. So it's f of x plus 3, because you take f of x, you bring it up 3 steps, and that's how you get g of x. So when, again, with these equations, it's all about translating those words. If you're going up, you know you're going to add. And if you're going down, like we had in this example, we're going to subtract. So it's one of those things, again, it might feel a little confusing because it's algebra, but at the end of the day, we're saying the same exact thing. It's just one way using words and one way using what we call function notation, algebraic notation. Questions on how to write the function notation, the algebra? Ooh, good point. Somebody in the chat. You could do it, yeah. Okay, so Samantha brought something up. You could do it backwards as well. So if I want to get to f of x, what do I do to g of x?
Subtract.
Mm-hmm. So if you go backwards, you take g of x minus 3. Because now you're going the other way, right? This time you go down 3 units. So it really just makes sure when you're reading that equation, you go the right way. You go in the right direction. And another good point in the chat is this graph, are f of x and g of x increasing or decreasing?
Is g of x increasing?
Both of them, because remember, when we shift it, we don't change the direction at all. So both of them, are they both increasing or decreasing?
Decreasing?
Decreasing, yeah. Decreasing, because you always want to picture yourself going from left to right. So from the left side, if I'm a little person over here, I'm going to be sliding down. So I'm decreasing. How about in this one? Were they increasing or decreasing in this one?
Increasing.
Increasing.
Increasing. Good. Good. Okay. Here's a test question. This is literally what it would look like. I copied and pasted this from an old test. So the coordinate plane shows the graphs of 2 exponential functions. Which equation is true? So take a look and be very careful because we know it can go one way or the other. Matter of fact, let me put a poll. And remember, guys, with the poll is always anonymous. So I encourage everybody to answer it because I won't know who answered it, but I'll know how many people answered it. So I'll know if there's only, if not everybody put an answer down.
Ms. Lopez, are you able to zoom into the graph?
Yeah, I can zoom in a little bit.
Easy,
There you go.
I think.
Okay, we'll see. Okay, I'll give you guys about 30 more seconds.
I might have chosen the wrong answer by accident.
Okay, Mr. Oh, this is so easy. You talk big game, sir.
I think, I'm not sure. I
Okay.
looked back and I'm not sure if I chose the answer I wanted to or not.
Okay. It'll all be revealed in about 10 seconds, so keep answering. I see almost everybody put it down. So 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay. Very interesting results, y'all. Very interesting results. So there's a 3-way tie. So we all decided D is definitely wrong. That's fine. But one thing one thing that's very important is that D is wrong. There's one more answer that's definitely wrong. Which one is it? Which one
C.
doesn't look? Yeah. Okay. So C and D are written incorrectly. Let me go back for a moment. Look at the way I wrote these algebraic notations. Look at the way I wrote it. The threes, the +3 and the -3 are outside of the parentheses. And that's very important to notice because when they go inside the parentheses, that means a completely different thing. So make sure, most importantly, that you're looking at the answers where the 3 or the constant, the number, is outside of the parentheses. Because what that's saying to you, what that's saying to me, is that you're going to take, it's like you can grab f of x and then bring it up 3 units. Or I'm going to grab g of x and bring it down 3 units. If you put that number inside of the parentheses, that's telling me that you're grabbing just the x, not the whole function. It's kind of a little weird, but just remember, outside of the parentheses.
Because
So-
inside that means you're gonna move f of x to the right or to the left. Or to
Good, you remember that. Good. It's exactly what that means. So good job.
I got it right.
So it's either A or B. Now we just have to figure out which one's saying things correctly. Because if you notice, they make a little change, and a little change goes a long way. So A is saying f of x minus 5 equals g of x. So A is telling me to grab f of x and do what to it?
Subtract 5.
Bring it down. Yeah. So this is telling me to take f of x, bring it down. So if I take f of x, I'm going to look at the y-intercept, and I bring it down 5 units, do I get to g of x?
Yes.
I sure do. I sure do. A is the right answer, but let me look at B as well, because B says almost the right thing. It just says it backwards. B is saying that f of x is when you take g of x and bring it down 5 units. But if I go to g of x on my graph, it's telling me to take g of x and bring it down. If I take g of x and bring it down 5 units, am I going to get to f of x?
No.
No. So how would I fix answer choice B to make it correct?
A addition sign?
flip it
Yeah.
around.
Yeah.
Oh.
If I turn that -5 into a +5, I've got a right answer. I've got a right answer. Because it's all about the direction that you go in. So this is telling me take f of x, bring it down 5 units. This one's taking g of x up 5 units. So you really have to train your brain into reading it in the way that it's written. So it's kind of like, I'll do a couple more examples so that you can get a better sense of it. But the sign really matters. The sign, the symbol, if it's minus, it's going down. And if it's positive, it's going up. So any questions on this one? Okay, let's do another one. So in this case, the graph of f of x equals 2 to the power of x is shown below. What's this equation again? What's that called? This one's a special one.
Parent function.
Yeah, this is our parent function. Okay, then it says, what is the graph of f of x equals 2 to the power of x plus k if k equals -2? So what this is telling me to do is, and I'll zoom in a little bit because I know it's kind of small. So this is telling me, okay, what is the graph of f of x equals 2 to the power of x plus k? But then they're telling me that k is -2. So I'm going to replace that k with -2. So I have my original parent function, which of these answer choices is going to be my new function? I'll put the poll up on the board. Go ahead and answer when you can.
For which one?
What do you mean?
Oh.
It's multiple choice. So which of those graphs shows the correct transformation? All right, I'll give you guys about 20 more seconds if you haven't chosen your answer yet. It's looking a lot better on this question, so more people got this one right, so good job so far. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, let me share the results. Most people chose answer choice A, and that is the correct answer. So let me go ahead and explain real quick because I did have a few people get the wrong one. So I just want to make sure. -2 means I'm going down 2 units. So first, let's determine where do I begin. So what's my original y-intercept?
One.
1, right here. So I start at the 1. So if I go down 2 units, where should I end up?
-1.
-1. So the only graph that's crossing through -1 is answer choice A, right here. So this one would be f of x minus 2. Okay, because I'm bringing it down 2 units. What would answer choice D be? Take a look at D for a moment. How many units did that one go down?
3 units.
3 units. So this is f of x minus 3, because this is what happens if you bring it down 3 units. What about answer choice B?
It went up 2 units.
2 units?
1 unit.
1 unit. So this is f of x, let me make it green, plus 1. And what about C? C is a little bit different, isn't it? C went, instead of going up or down, C kind of, if you look at it, you can tell C shifted in which direction?
To the left.
To the left. So that one's a little bit different. But any questions on this one? This one went a little bit better.
For
Okay.
C, I believe it will be f parentheses x plus 1 or -1.
For C, it's a little hard. I can't tell how far to the left it went. It's a little harder to tell because I think it went to the left and also down a little bit. So that one's just like a lot of transformations happened in that one. So I don't know for sure. Okay, one more, I think. Yeah, one more. Okay, so take a look. Use the graph to answer the question below. Which function represents the graph? Which function represents the graph? This one's a little bit more challenging, but I'm going to give it to you guys. I'm going to let you answer it on the poll, and then we'll definitely go through it together. All right, 30 more seconds. 30 more seconds to work it out. Ten, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, here are my results. The most popular answer was C. Doesn't mean it's correct, but let's take a look. So this one's a little more challenging, right? Because they don't give you the original function. They just show you a function, and they're trying to get you to figure out what was the original function. So looking at the answer choices, what does it look like the original function used to be?
B.
Like if I just had f of x equals something, no addition, no subtraction, no nothing, what would the original function be?
Oh, X.
Just 3x.
Just 3 to the power of x. Good. That's the original. All the answer choices, what they do is they start to change things about 3 to the power of x. So first thing is we got to figure out, is this 3 to the power of x, or is it 3 to the power of x plus something minus something? Let's find out. 3 to the power of x, what would be the y-intercept?
1.
Good. And the growth rate?
3.
3. Because remember, whenever you just have a number to the power of x, I could rewrite it as 1 times 3 to the power of x. So that would give me my y-intercept and my growth rate. Well, is this graph the graph of f of x equals 3 to the power of x? Does it have the correct y-intercept?
No.
No.
No. The y-intercept in my graph is 2. So how would I go? I know that I have a new graph. It's 3 to the x and then something. I might add something, I might subtract something. What should I do to the graph so that the y-intercept is 2?
Oh no. Wait. So
What should you do to the graph?
What should I do to the equation?
we have to subtract it because 2 by subtracted of 1 equals 1. Okay, and now I see why they chose C.
But be careful, because I think you're thinking backwards. What do I do to the original graph to turn it into the new graph?
You add 2.
I add
1.
1. I add 1. Because my original graph was, let me draw it. It's not on the picture. Let me actually put it there. My original, hold on, I don't want to confuse you guys. Original is going to be green. My original would look something like this. We know that the y-intercept of the original would be 1. The y-intercept of my new graph is 2. So that means that I had to take the original one and bring it up just one little step, just one step up.
Oh, I thought we were looking at g of x and we have to subtract it to make
Yeah, you were going backwards. That's what I knew that was happening. But that's okay. So now my new graph, the one that's actually here. Okay, I know that my new graph is the old one plus 1. So answer choice D was the correct one. Answer choice C would be if the graph was down by 1. So you just had to be very careful about, is it going up by 1 or is it going down by 1? And D is the one. So this one was a little bit more challenging. Do I have any questions? A couple of people who got it right were surprised to find out that they had it right. So good job to those who got it right.
I was
So it was
debating
tricky.
on C or D because of the reason I said before. for C, but then I chose D.
Mm-hmm. Let me explain it one more time because I have a couple of questions coming in. So again, the actual graph that they're showing us is the transformed graph. Matter of fact, let me write that down. What's on the coordinate plane is the transformed graph. We don't know what the original one looks like. In this example, they showed us the original one. And in this example, they showed us the original one, right? And then all we had to do was look. But in this one, they don't show us the original, they just show us what it looks like after the transformation. So we had to realize that the original one, 3 to the power of x, before you add 1 or subtract 1 or do something to it, the original one had a y-intercept at 1. So the original graph would look something like this. They don't show it to us, but just from the equation, we know that that's what it should be. So then the graph that they do show us, the transformed graph, is up 1 step from the original. It's just +1. So that's why D is the correct answer, because they transformed it by bringing it up 1 step, not by bringing it down 1 step. Okay. So that one, again, trickier, but how do we feel? Any questions now? How did I know the original one? How did I know the y-intercept of the original graph would be 1?
Because there's gonna be an invisible 1 for A, since there's no there's no number for it. You should note that if there's no number, that means it will equal just.
Yeah. There's an invisible 1 in front of it, and that 1 right there, that's my y-intercept. Okay. Cool. Any other questions? Okay, cool. All right. So we kind of finished a little bit early. We have 10 minutes left. So I'm going to switch gears. We're going to do something kind of random. It's going to feel random right now, but it's going to make more sense during tomorrow's class. I just want to spend 10 minutes doing a quick review of converting percents to decimals. So it's kind of different, you can take a moment, take a breather. No more crazy graphs, no more growth rates, no more y-intercepts, none of that. We're just going to do a little bit of basic math for a second. So I'm going to write down a few problems on the board, and I want you guys to copy them onto your notebook, and then after a little while, we'll go through them together. So just start by writing them down. Oops. Okay. So we're converting the following decimals into percents. So go ahead and copy them down and fill them in if you know how to do it. If you'll feel comfortable with it, go ahead and fill in your answers. Take about 2 minutes to do so, and then we'll go through it together. Alrighty. 0.38. How do I,
38%.
good, 38%. How do you do that? What are a couple of strategies? How do I turn a decimal into a percentage? Anyone can answer that.
You turn it into 100. Like,
So yeah, so what I would do, well, there's like a couple of ways, but one way to do it, just multiply it by 100. So 0.38 times 100 times 100 gives me 38%. 38%. Now, another way to do it, I see it in the chat, is just to move the decimal over 2 units to the right. So 1, 2 gives me 38%. So those are 2 strategies. One other way that I like to do it, sometimes it works better for me in my head, is to think about money and pennies. So if that was money, that would be 38 cents. 38 cents, that's 38 pennies. So 38%. So there's kind of a few different strategies to do it. Whatever works for you is whatever you should go for. So if you feel comfortable doing it one way, then do it that way. I'm not going to tell you which way to do it. What about 0.4?
40%.
Good, 40%. So again, if you multiply it by 100, that works. If I'm moving my decimal point, I got to do it 2 times. And since I don't have a number in that second spot, we always fill that with a 0. So it becomes 40%. What about 0.04?
4%.
4%. Good. Same thing. Move it over twice. You can think about it, this is 4 cents, 4 pennies, 4%. 0.52.
52%.
52%.
Good. 0.025.
2.5%.
Good. 2.5%. So this one, when you move it over twice, the decimal ends up between the 2 and the 5. And then the last one, 0.238.
23.
23.8.
Good. Good, good. Questions on going in this direction, turning a decimal into a percent? Okay, let's go the other way. Same idea, write all of these down, go through them on your own, and then we'll go through them together. Okay. Okay. So go ahead, take about a minute to fill in as many as you know, and then we'll go through it together. Alrighty. Now let's go through it together. 25% as a decimal.
0.25.
0.25. So again, this time we're going the other way. So that decimal place goes backwards 2 steps. 37%.
Is 0.35. 37.
0.37. Very good. 3%.
0.03.
0.03. Good. So again, we fill in that spot with a 0. So if I move this over twice, I got to fill that spot with a 0. 3.8%.
0.038.
Good. 0.38. 0.5%.
0.005.
0.005. Very good. So again, this one's a little bit tricky. Just make sure you have the right amount of zeros because we're moving this guy 1, 2 steps over. So when you move it 2 steps over, we get 2 zeros in front of the 5. And then lastly, 17.5%.
0.175.
Good. All right. Well, that is that. And I promise it looks random now, but it'll be more relevant in tomorrow's lesson. So good job today, guys. We've done a lot of work. We've learned a lot. So keep that up tomorrow. You've been doing really great. Just a reminder that there is homework. Some of you have already finished it. That's awesome, but it's due tomorrow at midnight. So if you haven't started on it yet, please get to it as soon as you can today. All right. So have a good day, everybody.
Have a nice day, Ms. Lopez. See you tomorrow.
Have a nice day. Bye, everyone.